All right, today we want to look at a very important question under motion, and it says a body starts from rest and moves with a uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? What distance does it cover in the third second? All right, this question is very simple, but it can be very tricky because most people will just use, for the fact that they say third second, they will just say three. They will use time for three and then use it to solve. And interestingly, it will not give you the answer. All right, what we're going to do here is very simple. It's just like a body starting from rest. Let's say, when a body starts from rest, of course, the initial velocity u is equal to 0. All right, it started from rest. It wasn't moving before, so the initial velocity is equal to 0. Okay, then it says that this body moves with a uniform acceleration of 6 meters per second squared. All right, let's write the value of acceleration. Acceleration A is equal to 6 meters per second squared. All right, they said, what distance does it cover in the third second? So the distance that it covers in the third second is the difference between the distance it covers for 3 seconds and the distance it covers for 2 seconds. Let's say the body started from here, this is the 0 second, that is the starting point. Then the first second is here, that is 1. Then here is the second, that is from here to here is now 2 seconds. And then the point here is now our third second. The distance we want to find is the distance from this second point and this third point. That is the distance that is covered in the third second. All right? Okay, now what we're going to do is, first of all, we find the distance it covers for 2 seconds. We also find the distance it covers for 3 seconds. And then we take the difference. That is, we subtract the distance of this second and the third second. That is, we subtract the two. Whatever we get is the distance from here to here. All right, so the formula is simple. We use S3 minus S2. This S3 here is the distance covered for 3 seconds. Then this S2 here is the distance covered for 2 seconds. All right, so coming down here, we now have that our S2, or rather, let's find S3 first. S3 is equal to UT plus half AT squared. All right, so let's substitute the value. U, of course, U is equal to 0. So everything here will multiply, like 0 times the time. The time here is 3. 0 times 3 gives you 0. So everything boils down to 0. So what we have left is half AT squared, which is equal to half times A here is 6. Then the T in this case is 3. We have 3 squared. And that's, okay, we can cancel out. This cancels, we have 3. 3 squared is what? 3 squared is 9. 9 times 3 is 27. So what we have here is 27. All right, let's find S3. Okay, we have found S3. Let's find S2. S2 in this case is still half AT squared, which is equal to, we have half here, then our A is still 6, then our T in this case is 2. All right, so we have to raise it to power 2 squared. Going forward, we cancel out. 2 cancel itself is 1. Cancel this one is 3. All right. Then 2 squared is what? 4. That is 2 times 2 is 4. 4 times 3 is what? Equal to 12. So finally, we have that our S3 minus S2 is equal to 27. That is the value for S3. Then minus S2 is 12. All right. When you now take the difference, you are going to get 5. That is 15 meters. Okay. So the distance from here to here is 15 meters. That's what it means. Then the distance from the beginning to this last point, that is the distance for 3 seconds, is what? 27. All right, the distance for 2 seconds, right, from here to here is what? Is 12. Is that okay? That's what it means by implication. So the distance from here to here, the last second, that is the third second is 27 minus 12, and that is equal to what? Is it really 15? Oh yeah, it should be 15. Yeah, exactly. It is 15. So this is the final answer, okay? So I believe that this helps. Whenever you see this type of question, don't rush to go and use 3 and begin to solve, because when you do that, it's going to land you to this particular value, and that is not the final answer. You would need to subtract the distance just for the second, okay? For you to be able to get the final answer. I believe that this is helpful. Thank you very much, and bye.